Okay, so the next question that we got on the menu today is asking us about some equivalent capacitors. Okay, so this will be a nice and fun question. Let's get it cracking. Okay, cool. So the first question is asking us, what is the equivalent capacitance between points x and y on the entire capacitor network? Answer in I 1/4 F. I'm going to assume, so I did a little bit of background research. This is not a real unit. I'm going to assume that I 1/4 F, this means microfarads. Equal to that, which is equal to 10 to the negative 6 farads. Okay, that'll be what I'm dealing with here. I think that might be like a technical issue, but let's redraw the circuit here. So typically I don't really like drawing voltage sources like this with capacitors because it can look a little bit too similar. I prefer to draw it like this. So we got 106 volts, and then here, okay, this would be our first node in our equation right here. So here we got a capacitor that's 11 microfarads. Here we got 14 microfarads. That's connected to a 14 like this. And there's another 14 like this. And over here we have 3 14s that are in, we got 3 14s in series like this. I'll just draw it this way. It really means the same thing. I know it's not perfectly the same as the diagram, but the circuit is perfectly equivalent. Okay, so it's another important skill to have, is to kind of know what circuits look like. And now it says, what are the equivalent capacitances between points x and z, between points y and z? I don't see any y's or z on here, but I think what they really mean is like, if this was y and this is z, so equivalent capacitance of circuit. Okay, so these are, it's very similar to maybe in the past you've seen simplification of resistor networks with capacitors. It's very, very similar, but one minor difference. So in parallel, so parallel C's, CEQ is just the sum of the C components. Now for series capacitors, the equivalent is very similar to how you would find the parallel resistors. Okay, so it's going to be the sum of 1 over the C component, and that whole thing to the power of -1. Okay, so to start this off, let's identify sections that we could simplify rather easily first. Okay, so here we have these 3 series capacitors. So the CEQ, let's call the CEQ1. This will be equal to, well, they're all the same. They're all 14. So it's going to be like 3 multiplied by 1 over 14 microfarads to the power of -1. Okay, so it's going to be, just from quick math, 14 over 3 divide 3, and that's going to be This is going to be 4.67 microfarads. And that makes sense because capacitors in series will have lower capacitance than any one of their components, and all of them are 14, so it should be less than that. I'm pretty sure that's 1/3 of 14, so that's another interesting thing. So if we want to redraw the circuit, we can redraw it like this. I'll copy over what we have that can stay. Like that. Copy that. Paste it down here. Now this is a pretty repetitive process, but this is quite important. Quite important. Okay. Okay, so we replace this entire triple series capacitors with a single capacitor like this. 4.67 microfarads, like that. Okay, now here, let's do this in a different color. We got a couple blues. So this will be parallel. CEQ is just going to be 14 microfarads plus 4.67 microfarads. Equivalent parallel capacitors, those are nice and easy, so this will just be 18.67 microfarads. Okay, so to redraw our circuit one more time, we're going to have something like this, 106 volts. Here we're going to have 11 microfarads, 14 microfarads. On the top was also 14. And over here we have 18.67 microfarads. Okay, now let's do a different color, green. It is a very progressive process, but there's nothing to be worried about. You can see here in green we have series. Okay, I'm going to just zoom out a bit and extend the vertical length of my page. Maybe I'll just move everything upwards like that. Okay, cool. So back to business here. So our series here is going to be CEQ. So we're going to need to add up all the inverses. So we have 1/14. Then we have 1/18.67 microfarads. Plus another 1/14. Whole thing to the power -1. Meaning just like 1 divided by it. Okay, so we got, let's do that math real fast. So 14 to the power -1 plus 18.67 to the power -1 plus 14 to the power -1. Close the bracket, everything else to the power -1. And here our result is 5.09 microfarads. Okay, so our final thing here, okay, we don't have a solution there to verify, but that's cool. So the circuit drawn one more time. This will be the last time we draw it. This will be 160, 106 volts. Here we got 11 microfarads. Here we got 5.09 microfarads. And as we can see, well, the CEQ of this one, let's put that in red, is really just going to be 11 microfarads plus 5.09 microfarads. which is just CEQ of the whole circuit is just 16.09 microfarads. Okay, so okay, I lied when I said this will be the final redraw, but this is like the actual final redraw. So 106 volts and 16.09 microfarads. Okay, so this is the final equivalent capacitance. See, it's really nothing particularly that's too difficult, but you know, there are a lot of steps involved, and you have to be very precise when you traverse through every step, because if you make an error in step 1, like if we made a mistake when like on the first part of our sequence here, like it would crash the boat for the rest of it. So you have to be very precise and double check before moving on, because if you find an error in your calculations deep like much later, it's going to be painful to try to track down what caused it earlier on. Okay, now the second part of our question, just to get a little bit more space, we'll get up here, is asking us what is the charge on the 11 microfarad capacitor centered between YZ. Okay, so pretty much what we know here is that we have what's pretty much asking us is we have our voltage source here, 106 volts. Here we have 11 microfarads, and here we have like a whole other of circuit, which is not really particularly relevant for this. We are looking for the charge on just the 11 volter. Okay, now the reason why the other part of the circuit is not really relevant is because we know that the voltage is always the same for the rest of the circuit, right? So the voltage between YZ, so VYZ, actually I'll do ZY instead to make it a little bit more formal. This is equal to 106 volts. Okay, so you know, as it's very clear on the voltage source side, we know that there also has to be 106 volts of difference across the capacitor and across like the whole right side of the circuit here, which is not particularly relevant. That's going to be 106 volts as well. Okay, now we know that the charge on capacitor, charge of capacitor equation looks like this. So we have Q equals CV. Okay, so we're pretty much just trying to solve for Q, because it's asking us the charge. Q is the charge, so we just got to multiply 11 microfarads. So Q equals 11 times 10 to the negative 6 farads multiplied by 106 volts. And that should give us the voltage, I mean, not the voltage, that should give us the charge on the capacitor. So let's ask our calculator. 11 times 10 to the power of negative 6. Multiply that whole thing by 106. And we get our charge is equal to 0.00117 coulombs. And 1, 2, 3. Another way we can write that is 1.17 microcoulombs. All right, so micro is the same as 10 to the negative 3, so that's pretty much what we got here. So this would be the charge on 11 microfarad capacitor, and that would be awesome. Okay, so that would be how you find the charge on the capacitor. Q equals CV. Don't forget that equation. Capacitor charge. It's a pretty nice equation. Can't lie. Okay, cool. So that pretty much concludes this this question. Yeah, awesome. So is no given solution to verify appears blank to me. Cool, so I would love to answer this question, but we are kind of getting tight on time here. So I do need to wrap this up here. Okay, let me switch over to my screen real fast so I can mention a few things. So those are all the questions that we have for today. If you enjoyed today's Q&A and would like to be notified of when we have our next live stream, please hit the subscribe button and ring the notification bell. If you would like to submit your own questions, check out the links in the video description below. Remember to leave a like and a comment, and if you really like the video, share this video with your friends. This has been Millen from OneClass. I hope to see you again soon for more fun with physics, math, and everything in between. Had a great time. Physics is always fun, and I hope you have an amazing rest of your day. And don't forget to stay safe and enjoy the physics.